Several potential operating problems could apply equally to two-phase or three-phase separators: foamy crude, paraffin plugging, sand production, emulsions, and carryover or blow-by.
The major cause of foam is impurities in the crude oil that are impractical to remove before the flow stream reaches the separator. Foam presents no problem within a separator as long as the internal design assures adequate time or sufficient coalescing surface for the foam to break. However, foaming in a separator does present certain design problems. Mechanical control of the liquid level is complicated because any control device must deal with essentially 3 liquid phases instead of 2.
Foam has a large volume-to-weight ratio. Therefore, it can occupy much of the vessel's space, which could otherwise be available in the liquid-collecting or gravity-settling sections.
Separator operation can also be adversely affected by an accumulation of paraffin. Coalescing plates in the liquid section and mesh pad mist eliminators in the gas section are particularly prone to plugging by accumulations of paraffin. Where it is determined that paraffin is an actual or potential problem, use of plate type or centrifugal mist eliminators should be considered as alternatives. Manways, handholds, and nozzles should be provided to allow steam or solvent cleaning of the separator internals.
Also, in horizontal three-phase separators, one major problem is the accumulation of sand and solids at the bottom of the vessel. To remove the solids, the separator is temporarily taken out of operation. Sand drains are opened in a controlled manner, and then high-pressure fluid, usually produced water, is pumped through sand jets to agitate the solids and flush them down the drains. Even minor amounts of sand can cause accelerated corrosion of vessels at high throughput volumes.
Unfortunately, the separator design that provides the best mechanism for separating the gas, oil, and water phases probably will also provide areas for sand accumulation. A practical balance for these factors is the best solution. Emulsions can be particularly troublesome in the operation of three-phase separators.
Over a period of time, an accumulation of emulsified materials and/or other impurities may form at the interface of the water and oil phases. In addition to causing problems with the liquid level control, this accumulation will also decrease the effective oil or water retention time in the separator, with a resultant decrease in water-oil separation efficiency. Addition of chemicals and/or heat often minimizes this problem.
These techniques, however, are more commonly applied in the oil treating portion of the processing facility, as we shall see later. Two other common operating problems are carryover and blow-by. Carryover occurs when the liquid escapes with the gas phase and can be an indication of high liquid level, damage to the vessel's internal components, foam, a plugged liquid outlet, or an improper design, or simply exceeding the proper design rate of the vessel. Blow-by occurs when free gas escapes with the liquid phase and can be an indication of low liquid level, vortexing, or level control failures. All of these operating problems can be minimized by considering their risk of occurrence during the design of the separator. This requires a good understanding of the fluid properties, sand production potential, future rate projections, and the historical operating problems for the area.